the value of negative 4 minus 3i is also 5. All right, so in part 4, we're looking at the powers of I, and there's going to be a pattern that we're going to have to discover here and be able to use. But first, we'll start with I to the first. Put it up here. Okay, that's the square root of negative 1, which is obviously I. So we know I equals I, the reflexive property. Okay, but now we have I squared. Okay, I squared would be I times I, which is the square root of negative 1 times the square root of negative 1. Remember, when we multiply a radical by itself, that radical piece just cancels out. You're left over with the radicand. It's negative 1. So that's an important piece of information there. I squared is actually simplified to a real number, negative 1. Okay, I to the third is going to be I squared times I, which is negative 1 times I, which is negative I. So I to the third simplifies to negative I. I to the fourth, that could be I to the third times I, which is negative I times I, which is negative I squared, which is the opposite of negative 1. Remember, back up here, I squared was equal to negative 1, which is 1. So I to the fourth simplifies to 1. And take a second, try to figure out what I to the fifth through I to the ninth equals. You might be able to see a pattern start to develop. So I'll pause it here. You can work on it on your own. So hopefully you work those out. There's my answers over here on the left side. So if you look at our pattern here, I mean, how many powers of I do we really need to know? Well, you look at the first 4. That's where the pattern starts to repeat. These are the crucial ones right here. So we know that I to the first is I. I squared is negative 1. I to the third is negative I. And I to the fourth is 1. Those are the key ones that you have to know. And then you see the pattern starts to repeat after that. It starts to cycle back over itself. Okay, these are called the iterations of I. Okay, and this is kind of important because every complex number can be written in A plus BI form. And notice that that BI has an exponent of 1. So this BI term needs to simplify either into a real number, if it's I squared or I to the fourth, or into a term where the exponent of I is 1, like in I to the first is I, or an I cubed is negative I. Okay, so we can simplify all these complex numbers into this form, right? We shouldn't see any other exponents of I other than 1, right? So we can easily see in this next example, we can figure out what I to the 365 is. All we have to do is take 365 and divide that by 4. So I know that goes in 9 times. There's 36. Bring down your 5. So I got 91. 4 subtract. Get 1. I got 91 with a remainder of 1. So I to the 365 is equal to I to the first. All we have to do is look back up at our powers of I, our iterations of I. I to the first is equal to I. So I to the 365 simplifies to just I. Take a second and figure out what I to the 3,295th power is. So when I divide 3,295 by 4, I get a remainder of 3. So I to the 3,295 is equal to I to the third, which from above is negative I. That's what it simplifies to. So moving down to example 5, we can do all sorts of operations with complex numbers. I can add them, subtract them, multiply them, divide them. I mean, simply if I want to take this a1 defined as negative 5 minus 2i and add it to a2, which is negative 3 plus I. So we got negative 5 minus 2i plus negative 3 plus I. I would just add the real pieces together to get negative 8 minus I. So add the real pieces together, add the imaginary pieces together. So it simplifies to negative 8 minus I. If we look at a1 divided by a2, that's going to be negative 5 minus 2i over negative 3 plus I. And if you think back to last unit, unit 8, we're not allowed to have a radical in the denominator of a fraction. Well, here we're also not allowed to have an imaginary in the denominator of a fraction. So we have to take steps to make this denominator into a rational number. Just like we had in unit 8, when we had a binomial type term in the denominator with a radical in it, we used a conjugate. Well, we can also use a complex conjugate when that binomial term happens to be a complex number. So here, if a plus bi is in your denominator, the conjugate is a minus bi. Just change the sign in the middle there. And similarly, if a minus bi is your term, the conjugate is a plus bi. So back up here in this example, I'm going to multiply by the equivalent form of 1 with negative 3 minus I over itself. Now the numerator we have to FOIL. So again, we can FOIL this just by using our properties of exponents and everything that we need. So I'm going to have 15 plus 5i plus 6i plus 2i squared. Okay, well, we're going to simplify this into a plus bi form. So we'll take that next step. I'm going to have 15 plus 11i, that's 6i plus 5i, plus 2 times, well, I squared is negative 1. So that's 2 times negative 1, which also combines with the 15. So 15 minus 2 is 13 plus 11i in our numerator. So there's our complex number there. You see it simplifies into that a plus bi form that we need. The denominator, if you remember the conjugates, the o and the I terms are going to cancel themselves out in FOIL. So that's going to be 9 minus I squared. Well, again, I squared, that's a real number. That's negative 1. So that's 9 minus negative 1. 9 minus negative 1 is 10. So there is your complex number. Okay, 13 plus 11i over 10, and that's in simplified form. So again, you're not allowed to have imaginaries in the denominator. And here, if I were actually doing this lesson in front of a live class or actually in person, I would have the class look at their calculators to find the imaginary number I. Okay, you can see if you were to take your graphing calculator out, you hit second and the decimal point. Okay, you see that I right there, and this can simplify any one of these complex fractions for you. So it is important that you understand how to perform these operations with the complex numbers, with the addition, subtraction, multiplication, and division, but you can easily check your work with your calculator by plugging it in there as well. So that concludes today's lesson. Thanks, stay well, and have a good day.